seas and oceans cover over 2/3 of the surface of the globe. What we see as individuals are normally the margins and the surface of the enormous volume of water that encircles every continent and island. For the majority of us, our impressions of the sea are often formed by such things as how calm or rough it is, how visually clear or otherwise, and by the context in which we view it. Is a channel crossing likely to be rough? Is the water clear enough to dive in? And are the waves high enough for surfing? And so on. But the sea holds many more secrets and valuables than we can hope to uncover by simple visual inspection, whether from the shore or from a ship. Because of their sheer scope, the oceans and seas exert a major influence upon our environment. They can provide a means of travel and relaxation. They can provide exploitable resources, such as food and hydrocarbons. They are used as a dump for waste products. They have a major influence on climate, and they conceal rich resources of information on matters which may be regarded as solely of academic interest at present. Since man first embarked upon the seas, he has gathered information about it, its currents, its weather patterns, its inhabitants, and much more. In the past few years, satellites have opened up new vistas of data collection, principally that of synoptic viewing of the sea surface and the geoid. However, despite these advances, for many of the measurements that scientists wish to make, or material they wish to collect, the only practical solution is to take a ship to the appropriate area and drop into the sea the relevant measuring or collecting devices. Research ships and the scientific equipment are too costly for any one organization to operate. So NERC, on behalf of the United Kingdom scientific community, funds and operates Britain's oceanographic research fleet. This film is about the ships and their technical support which make marine science possible, and some of the developments which benefit the United Kingdom in both the short and long term.
NERC's research vessel services, based at Barry in South Wales, were set up some years ago to provide the scientific and technical support necessary for the marine research funded by NERC, both in universities and its own institutes. RVS supports 3 general-purpose research vessels and a pool of marine scientific equipment with a capital value of about £8 million.
There are 60 or so scientific support staff based at Barry, divided into 3 groups. The base engineering group is responsible for all the mechanical handling equipment on board the ships. This includes the A-frames, cranes, all the hydraulic power supplies, the winches and warps, and general equipment mounting and deployment capabilities. The shipborne instrumentation group has responsibility for ensuring that electrical and electronic equipment taken to sea by research teams is functional, well maintained, and properly calibrated. These aspects are particularly important for equipment that may be required to function effectively for up to 700 hours continuously on any cruise. The shipborne computer group not only supports computing at sea, but has also been responsible for the development of the ABC computing system, which is now fitted as standard to NERC's 3 general-purpose research vessels. These 3 groups provide the essential support for the operation of the ships.
The ships operated by NERC are uniquely entitled to carry the prefix RRS for Royal Research Ship. They are direct descendants of early vessels that were pressed into marine research. The ship that I am standing alongside now carries the same name as the naval vessel that was sent on a round-the-world scientific expedition in 1872, an expedition that is accepted as marking the beginning of modern marine research. RRS Challenger is 54 meters long with a gross tonnage of slightly over 1,000 tons. She has a nominal endurance of 32 days between port calls and normally operates in temperate Atlantic waters, the Mediterranean, Caribbean seas. She can carry up to 14 scientists and specialist technical staff and is capable of supporting the whole range of marine sciences.
For 15 months, between August 1988 and October 1989, NERC has committed Challenger to an intensive study of the North Sea. The study involves a 2-week survey every month over a 1,200-mile fixed track to study the temporal variation of a range of parameters, interspersed with project studies where specific topics of interest are being investigated by teams of university and NERC Institute scientists. Marine science is not restricted to the high seas, and NERC supports research in inland waters and estuaries. The calenus is operated by the Dunstafnage Marine Laboratory with support from Research Vessel Services.
The calenus was purpose-built in 1980 for the SMBA as an inshore research vessel. Her main area of operations is the northwest of Scotland, although she is capable of working in the Irish Sea, the Hebrides, out to Barra Head, north to Orkney and Shetland, and down to Peterhead. Of particular interest is her ability to work both shallow and deep water. Locally we have both. Here in the Linn of Morvern, only 1 hour from Dunstafnage, we have a 200-metre trough, with another of 60 metres only 15 minutes away. With deep water in Loch Etive, we have an interesting mixture of salinities and depths. The calenus is equipped with the most sophisticated navigational equipment commercially available. We have the latest Decca navigator and the Decca colour video plotter. This not only makes navigation accurate and rapid, but readily accessible to the scientists on board. The latest daylight viewing radar complements the more conventional radar, giving us a navigational suite well suited to our inshore waters role. For a vessel of only 60 feet in length, the calenus has an extraordinary amount of space, 3 laboratories and comfortable sleeping accommodation for 6 scientists in 3 double cabins. The calenus was designed to take the laboratory's decompression chamber on the afterdeck. This, together with many other special features, make the vessel particularly attractive to all branches of marine science.
The flagship of Council's research fleet is the Royal Research Ship Charles Darwin, named after the famous scientist and ordered by NERC in 1982, the centenary of his death. This ship, at 70 metres long and 1,936 tons gross, has a worldwide operational capability. In June 1986, she began a 3-year programme of research in the Mediterranean Sea, the Indian and Pacific Oceans, and is expected to re-enter the Atlantic Ocean via the Panama Canal in the summer of 1989. Such international research is seen as essential by the scientific community because many marine processes occur in several oceans, and explanations of such phenomena may become apparent if they are studied in a variety of places. In addition, NERC and British marine scientists often possess expertise which is of value to foreign governments. The opportunity to carry out research in foreign waters can lead to financial support for that research or subsequent work. The design of the Charles Darwin reflects a number of lessons learned from earlier research ships.
Charles Darwin is the most modern and most sophisticated of the NERC fleet. She was built in 1984, and as you can see, we're covered with instruments. She's directly controlled from the bridge, the engines, through a variable pitch propeller, and the engine itself is also controllable, so you have infinite variation in the control you can apply to the ship. With a bow propeller as well, so for handling she's very, very good. easy to keep on station in conditions up to gale force, depending largely on the type of sea. From my point of view as a seaman, we have to work as a team. You have to work as a team right throughout the ship. You have scientists coming who are highly professional in their jobs and their approach to their jobs. We're professional seamen. By working together, there's very little we can't achieve that they want to do.
The large, clear afterdeck is covered by a matrix of bolt-down holes for the easy installation of a range of scientific equipment or containers. And these are continued along the clear starboard side deck. Current research equipment is tending to increase in size as scientists exploit developments in technology to probe deeper in both the physical and intellectual meaning of the word. And when this increased size is coupled with a trend towards multidisciplinary research activities, space for the mounting of equipment soon becomes critical. An example of this trend towards portability of larger equipment is shown by the Gloria system, developed by NERC's Institute of Oceanographic Sciences, Deakin Laboratory, but now marketed by Marconi Underwater Systems Limited under a technology transfer agreement. This equipment once required a permanent fixture, but can now be used on Council's larger vessels and on charter ships because of the new mounting arrangements. The largest of Council's general-purpose research ships is Discovery. Built in 1962, she is also the oldest ship in the fleet and reflects the philosophy of the time. Small afterdeck, a number of discrete laboratories, and constraints on the range of equipment that can be utilized. Nevertheless, the ship has been and continues to be committed to a full program of research, and like the other ships, can expect to be at sea for between 280 and 300 days each year. On several occasions in the past few years, she has carried out research in Antarctic waters.
The Royal Research Ship Discovery is the latest in a long line of ships to bear the name, a name which is synonymous with exploration and marine research. To provide quiet running and fine speed control, Discovery has diesel-electric propulsion. Her propeller is driven by an electric motor of 1,500 kilowatts, the power for which is supplied by 3 diesel-driven generators of 600 kilowatts. Normal economic running is on 2 of these engines, which give a speed of 11 knots. The Discovery also has a bow thrust unit, which provides maneuverability at slow speed and when on station. This unit can provide up to 6 tons of thrust.
NERC intends, if finance is made available, to carry out a major conversion of the ship in the near future to enable her to support marine scientific research for another 15 to 20 years. Each of the 3 ships can support research in any of the disciplines of marine science. In this presentation, we can only touch upon the main thrust of some of these disciplines, but these will illustrate something of the range of equipment and support needed by modern marine science. Geology and geophysics are currently dominant areas of research. The subjects cover a range of research topics from the collection of data to develop or improve models of the movement of the Earth's crust, through to exploration for mineral or hydrocarbon resources. Much of the research depends upon knowledge of the surface and subsurface topography of the seabed, and the special knowledge possessed by NERC's British Geological Survey in this respect was applied to the initial surveys on which the government based its decisions on the granting of exploration licenses for offshore oil and gas reserves. Gloria, which we saw a few moments ago, is towed behind the ship and sends sound pulses to the seabed. The reflected signal can be measured and processed to produce the underwater equivalent of an aerial photograph of the sea bottom. This British-developed equipment was the first of its type anywhere, producing pictures from a 60-kilometre wide swathe, which allows a mapping of an area the size of Wales each day. As a result, the United States Geological Survey placed a contract with NERC to survey the United States exclusive economic zone. Marine physics is concerned with studying the physical properties of the seas, the ocean currents, and their mutual interactions and influence upon climate. The principal physical properties of the seas, salinity and temperature, and the depth at which these and other data are gathered, are measured frequently on any cruise. At the same time, water samples may be gathered at a variety of depths for subsequent analysis on board ship. A relatively new technology that measures subsurface currents relative to the motion of the ship is the acoustic Doppler current profiler, or ADCP. The installation of this on the Charles Darwin was not without incident, the diver having to overcome a number of problems.
Any movement of the water relative to the ship will produce a change in the frequency that is transmitted from the transducers of this instrument, which are mounted in the hull. This change in frequency is directly related to the speed of the water movement beneath the ship. The instrument, as you see it here, will produce continuous records while the ship is moving at any speed, up to full speed, of water current movement, speed and direction at depths from the surface down to the region of 400 meters with this instrument. In certain conditions, if the echoes are very strong from the reflecting layers beneath us, we can achieve ranges of up to 600 meters beneath the ship. The biggest value of this instrument is that it will continuously measure water currents with the ship moving or at standstill, and although this will not reduce the need for moored current meters of the traditional type, the information from this instrument adds greatly to the information that the more conventional instruments give us, and a large area, and hence a lot of information, can be retrieved during one cruise.
The seas and oceans represent the last great earthly challenge. It is well known that we know less about the 2/3 of the Earth's surface covered by the sea than we do about the surface of the moon. For man to live in harmony with the oceans, we need to know more, much more, about the properties of the sea and the surface of the Earth that lies beneath it. To find out about those properties, we shall need to carry men and equipment to all parts of the world on ships. Ships that will have to be fitted out effectively to carry out scientific research with the most modern equipment, supported by properly trained technical staff. This is, and will continue to be, the role of research vessel services.